I'm Namrata. My team, consisting of Shravya and Varsha, are here today to talk to you about our project developed for the course of data mining techniques under Professor Sara as part of our curriculum at Northeastern University, Boston. We were fascinated by the real time application of prediction of sales based on the data obtained by observing previous year's data to enhance the Black Friday sales in the United States. This prediction will be beneficial to the store owners to both increase their profits and also manage their inventory effectively. We are exploring several data mining techniques here to predict the sales performance using a data set to determine something called as the RMSE score, which is the root mean squared error score, which would indicate the best prediction performing model. As for our data set, we have obtained it from Kaggle. The dataset contains 12 columns, and they are user ID, product ID, gender, age, occupation, city, category, the number of years the user has stayed in that particular city, marital status, the subcategories of product category, and purchase. Product categories are categorical data. Occupation data is changed from categorical to numerical. So we have made a few modifications to the data set that was obtained. We have pictographic box plot representations of some of the features like all three of the product categories, occupation, and purchase, which shows the distribution of data in the dataset, which helps us identify outliers, as can be seen for purchase column. Thank you.
Hi, my name is Varsha and I'm going to talk about methodology. After the exploratory data analysis, we found that two of the columns have a lot of missing values. Product category 2 and product category 3 were those columns. So instead of imputing the missing values, we just dropped the two columns from the data frame. For evaluation, we have chosen the metric called RMSE or root mean squared error. Root mean squared error is the standard deviation of the prediction errors, and it tells how concentrated the data is around the line of best fit. We experimented with 6 models, namely linear regression model, neural networks, decision tree, random forest regressor, gradient boosting, and XGBoost. Linear regression model is the simplest of all the models, so we chose it as the baseline model. It models the relationship between two or more explanatory variables and a response variable by fitting a linear equation to the observed data. Neural network is a network of small computing units where each unit takes a vector of input values and produces a single output. Coming to decision tree. Decision tree regressor is a supervised learning model which builds and uses a decision tree to predict the values. Random forest regressor is an improvement done on the decision trees where multiple decision trees are constructed and each tree predicts a value and the mean of all those values is taken and returned as the result. Gradient boosting is a variant of random forest algorithm where an algorithm called gradient descent is applied to minimize the loss functionality. XGBoost is an improvement done to the gradient boosting algorithm, but it is much better because of its performance and speed. It internally uses decision trees, and for our experiments, this model gave the best results. Thank you.
My name is Shravya and I will be continuing with the results. From the results obtained, we can see the least root mean squared error score is obtained for the XGBoost algorithm. This low score is indicative of the better performance of the model since it is designed for speed and increased performance than the gradient boosting machines and the other models on the same dataset. Conclusion. By performing the above experiments, we see that the linear regression models aren't very suitable for the regression problems when there are a large number of input variables and high non-linearities involved. Although neural networks can be seen dealing with non-linearities better, their RMSE scores are still poor. We see that the models using decision trees give better performances, with extreme gradient boost model giving the least RMSE value and the best performance. The random forest regressor and the gradient boosting algorithms perform better than the decision tree regressor, which is justified owing to the fact that they both improve the decision-making process of the regressor by implementing ensemble methods. Future work. The experiments that we performed used the values in the dataset directly. To enhance this, we could possibly improve the models by performing feature engineering. We can derive new features from the existing columns and train them for possibly better models. We can also perform the same experiments by dropping some of the features depending on how much training value they have. In addition, we can go ahead by replacing null values in the dataset with some appropriate values instead of dropping them altogether. To conclude, all of these could possibly improve the training data to give lower RMSE scores that produce better prediction models. Thank you.